Welcome, Shrikant. We will just start this today's concept. We are just waiting for 2 more minutes so that some other student will join this section. We will start section after some 2 or 3 more minutes. Welcome all. We will start the section after 2-3 minutes so that more students will join the section. Then we will start. Is this audible? Reply me in chat. Is this audible? Reply me in chat. Yes, Shrikant, good afternoon. We are just waiting for 2 more minutes, then I will start the section. We are just waiting for 2 more minutes, then we will start the section. Is this audible? Reply in chat. Suyash, mute your microphone. Suyash Shinde, mute your microphone. Suyash, I think your microphone is not mute. We are just waiting for 2 more minutes, then we will start the section. Okay, so here we start. I am sharing my screen. So the concept which we are going to study today is accumulator. So what is accumulator? We see in the last lecture about just introductory part of this accumulator. A hydraulic accumulator, it is a reservoir tank which stores oil under pressure by external source like gravity, mechanical spring, and releases that oil to system wherever required. What is accumulator? Accumulator, it is a device which stores high pressure oil which will be supplied when there is a need or requirement of more pressure during the peak period. At this time, the high pressure fluid which is stored in accumulator is used. Then how we are going to store this high pressure oil? We are going to store this by using the source like gravity, mechanical spring. And how we are going to use this hydraulic gravity to store the high pressure oil is we will see in today's concept further. So what is accumulator? Accumulator, it is a component which stores high pressure oil. The pressure energy stored in accumulator when the demand of energy by the system is less than that available from the prime mover, and it's released to the system during its period of peak demand of energy which the prime mover alone cannot meet. Here prime mover means pump. When the pump pumping the oil which is not sufficiently high, which is not completely used at this time, this accumulator stores this high energy, and when this pump is not capable to meet the required need of high pressure oil, at this time accumulator supports the prime mover and supplied its high pressure oil. Its function is analogous to the flywheel in a mechanical system and capacitor in electrical system. You know what is flywheel? Flywheel, it is a device which is used to store the energy. Same here, accumulator, it is a device in hydraulic system which is used to store energy in form of high pressure oil. Here in this circuit diagram, you can see where is accumulator is connected. Accumulator is connected at the high pressure side of this hydraulic system. Which is high pressure side? High pressure side is having pump. Then this pump is connected to the direction control wall here, and this direction control wall is connected to this actuator which is piston cylinder content. So after this pump, this accumulator is connected which contains high pressure oil. When the pump provides more than required high pressure, at this time this high pressure oil is stored inside the accumulator, and when pump is not producing sufficient pressure of oil, at this time this accumulator comes to help the pump by releasing high pressure oil contained in it. म्हणजे बघा, आपण मराठीमध्ये डिस्कस केलं तर आपण काय म्हणू शकतो, जेव्हा पंप खूप जास्त प्रेशरने ऑइल प्रोड्यूस करतोय आणि एवढं प्रेशर आपल्याला ऍक्च्युएटर मध्ये यूज होत नाहीये, त्यावेळेला आपण काय करू, ते जे हाय प्रेशर ऑइल आहे ते ऍक्युम्युलेटर मध्ये स्टोअर करून ठेवू. आणि जेव्हा पंपची कॅपॅसिटी आपल्याला कमी पडते त्यावेळेला आपण काय करू, अक्युमुलेटर मध्ये स्टोअर केलेलं जे हाय प्रेशर ऑइल आहे ते तिथनं विड्रॉ करून घेऊ. म्हणजे इथे अक्युमुलेटर काय वर्क करतोय, अक्युमुलेटर इज वर्किंग ऍज अ पॉवर रिझर्वायर, and in which form it is reserving power in the form of high pressure oil. So this is the circuit diagram I explained. It's in chapter number 1. It is pressure relief valve. So I just want to tell that here that this accumulator is connected towards the high pressure side of hydraulic system. So here we go to see the functions of accumulator. To work as a shock absorber. What is the meaning of this shock absorber? Shock absorber means when there is a production of vibration or production of some unbalanced force inside the system because of pump. At this time this high pressure wave is get absorbed by the accumulator, which work as a safety device for the hydraulic system. Then second number is to provide pressurized hydraulic oil whenever it is required. As we already telling you that, as I already telling you that this accumulator, it is a device which stores oil. So whenever we require this pressurized oil, it should be provided by the accumulator. Then second number, to compensate leakage problem in the system. Suppose there is a leakage problem inside our system and system is closed system. At this time the oil start coming out from the system due to this leakage. So we having this oil store in accumulator. So the oil which is getting leak from the system should be compensate or should get from the accumulator. Here meaning of what compensate can be taken as can be replaced. कॉम्पेन्सेट म्हणजे काय बघा, इथे सपोज तुमच्या अक्युम्युलेटर मध्ये 10 kg ऑइल भरलेलं आहे आणि आपल्या सिस्टीमला लीक व्हायला लागली आहे, सिस्टीम मधनं 100 ग्रॅम ऑइल पर आवर लीक होतंय. तर आपण काय करूया, 100 ml ऑइल आपल्या सिस्टीम मधनं लीक होते, तर आपण काय म्हणूया की ते 100 ml ऑइल आपल्या अक्युम्युलेटरने आपल्याला सप्लाय केलं पाहिजे. म्हणजे आपण काय म्हणू, टू कम्पेन्सेट द लिकेज प्रॉब्लेम. तुमच्या याच्यामधनं ते 100 ml लीक होत होतं, ते आपल्याला अक्युम्युलेटरनी कॉम्पेन्सेट करून दिले पाहिजे, म्हणजे ऍडजस्ट करून दिले पाहिजे आणि सिस्टीम काय झाली पाहिजे, रन झाली पाहिजे, सिस्टीम थांबायला नको. Next function is to energize the source of energy when power is shut off or pump is not working condition. सपोज काय झालंय की आपला पंप अचानकच बंद पडलाय, तर पंप बंद पडलाय तरी आपली सिस्टीम रन झाली पाहिजे, यासाठी आपण काय करू शकतो की आपल्या अक्युम्युलेटर मधनं जे आपण हाय प्रेशरला ऑइल स्टोअर करून ठेवलंय ते आपण यूज करू शकतो. म्हणजे whenever there is a problem of shutdown or pump working condition, whenever pump is not working, at that time this accumulator should come to help uh, and to energize the system, and system will remain in work. So all these are the function of accumulator. So in this slide we are saying about the design of accumulator. You can see this is the design for accumulator. Then we are here to see the classification. So this accumulator can be classified according to the gravity or according to the components it use. So first type is gravity or dead weight type. Another one is the spring loaded type accumulator. Third one is the gas loaded type. And gas loaded type again having two types. First one is the free contact type, which is also called as non-separator type, and next one is the separator type. Separator type, okay, separator type gas loaded again having three types: piston type gas loaded, then diaphragm type gas loaded accumulator, then back type gas loaded accumulator. So here is some videos of this accumulator. You just see, then I will explain it.
The main task of a hydraulic accumulator is to take a specific
Normally accumulator looks like this.
The main task of a hydraulic accumulator is to take a specific amount of fluid under pressure from the hydraulic system and store it until it is required within the system. In order to store energy and accumulate the fluid,
you can say inside accumulator can be look like this if we take its cross section.
Fluid in an accumulator is weight or spring loaded or pressured by a gas. There are three types of accumulators used in hydraulic systems. They are weight loaded, spring loaded, gas loaded, or hydro pneumatic accumulator. They are weight loaded, gas loaded, or pneumatic accumulator. Is maintained between.
So you can see here these are the normal three types of this accumulator. Gas loaded accumulator again having its different type. So what is accumulator? It is a device which stores high pressure oil, and how it is going to store this high pressure oil we will see during its working. So just see on your screen.
The pressure in a fluid and the opposing pressure produced by the weight, spring or pressure created from the gas.
इथे काय होतंय, जेव्हा हा तुमचा अक्युम्युलेटर आपण फ्लो लाईनला कनेक्ट केलाय, तेव्हा काय होईल, हाय प्रेशर ऑइल याच्या आतमध्ये इन्सर्ट होईल, आणि बिकॉज ऑफ दिस प्रेशर ऑफ ऑइल दिस ही जे वरती वेट आहे, दिस वेट मूव्स upward, and this weight makes a force on this oil which keeps it is in pressurized format. Okay, so here we are using this gravity weight to pressurize the oil.
Formulas for determining pressure are shown on the video.
Here we are using this spring to pressurize the oil.
The following types.
These are the types of gas energized accumulator. It is having again three types: membrane accumulator, bladder accumulator, and piston accumulator. In this gas loaded or gas charge accumulator, we are using this gas from one side to keep the oil in pressurized condition.
Accumulators with separating elements are used in industries: piston, membrane, balloon or bladder accumulators. Elements of a piston accumulator: body, piston.
This is the internal structure of this gas loaded or gas charge accumulator. You can see on your screen.
The main elements of a piston accumulator: body, piston seal, fluid cap, gas valve. Examples of application.
You can see here on your screen that this is the pump. This pump is connected to the direction control wall, and this direction control wall is connected to this actuator or piston cylinder here. So between this direction control wall and this pump, we are connecting a accumulator here, which is connected towards the high pressure side of this hydraulic system. This is what this is: pressure relief valve. It is also connected towards the high pressure side of hydraulic system. Okay. So here, this is the simple diagram for dead weight or gravity type accumulator. Normally what happens, you can see my, just focus on the cursor of your screen. Thus the pump is continuously producing high pressure oil which comes from this side, and when this high pressure oil starts to enter inside this accumulator, it starts to lift this dead load because this oil is under pressurized condition, and when this pump is not sufficient to produce the high pressure oil, at this time this oil from this accumulator starts to move downward, and this accumulator produces high pressure oil to this pipeline, which also works as a सपोर्टिंग टुवर्ड्स द पंप. बघा नॉर्मली काय होतं, जेव्हा तुमचा पंप खूप जास्त प्रेशरमध्ये ऑइल प्रोड्यूस करत असतो, तेव्हा ते हाय प्रेशर ऑइल जे आहे ते आपल्या अक्युम्युलेटरमध्ये जाईल आणि ते काय करेल, या डेड वेटला वर लिफ्ट करेल. डेड वेटचं प्रेशर त्यावर कंटिन्युअसलीच राहील. त्याच्यामुळे काय असेल, जे ऑइल आपल्या अक्युम्युलेटर मध्ये आहे ते कसं असेल, हाय प्रेशर मध्ये. आणि जेव्हा तुमच्या सिस्टीम मधलं प्रेशर कमी होईल, तुमचा पंप जेव्हा कमी प्रेशर प्रोड्यूस करत असेल, त्यावेळेला काय होईल, अक्युम्युलेटर मध्ये जे हाय प्रेशर ऑइल आहे ते काय होईल, सिस्टीम मध्ये खाली येईल, आणि तुम्हाला सिस्टीम मधलं जे प्रेशर आहे ते प्रेशर कसं असेल, युनिफॉर्म राहील किंवा कॉन्स्टंट राहील. So what we are using here, dead weight to keep the oil pressurized in an accumulator. That's why it is called as dead weight or gravity type accumulator. त्यानंतर इथे बघा, graphically we are trying to show this graphically we are trying to plot this fluid pressure against volume of fluid. So इथे जर आपण बघितलं तर the fluid pressure remains constant with respect to the volume of fluid in accumulator. Then the information description about this dead weight or gravity type accumulator is listed here. It consists of a vertical thick walled steel cylinder housing a piston. The piston rod extending out of the cylinder supports the dead weight by raising the piston on admitting high pressure. The force of gravity of the dead weight is used to store the potential energy. This accumulator generates a constant pressure of fluid through full volume output of fluid independent of rate and quantity of energy supplied from prime mover. इथे तुम्ही बघू शकता इथे काय आहे, this is the piston which is connected to this dead weight, and this piston moves up and down with respect to the pressure inside the system. When the pressure inside the system is high, at this time it moves upward, causes to enter more pressurized oil inside this accumulator, and when the pressure in this system is less, at this time this dead weight moves downward, causes to force this high pressure oil to pass to the system here. Okay, so here we are. Okay, so here we are taking the information about this spring-loaded accumulator. So the main difference between the spring-loaded and gravity accumulator is that in this spring-loaded accumulator, we are replacing this gravity, replacing this load with respect to the spring here. So here we are replacing this gravity load by the spring here. And when this high pressure oil comes inside this accumulator, because of presence of this spring and stiffness of the spring, this oil inside this accumulator remains under pressure, and this spring again send it back when the pressure inside the system reduces. So here just the load is replaced by the spring here. And when we plot this fluid pressure along with the volume of fluid in accumulator, we get the relation like this slant line here. So the information about the spring-loaded accumulator, it is similar to a dead weight type, except that piston is preloaded with a spring compression. The spring is a source of energy acting against the piston. The pressure created by this type of accumulator depend upon the stiffness and preloading of spring. The pressure exerted on the fluid is not constant. It is typically delivers a low flow rate of oil at low pressure. So for high pressure situation, this type of accumulator are somewhat heavy. These are not suitable for application demanding high cycle rates, as the spring may fail in fatigue and loses its elasticity. The life of the spring-loaded accumulator is less as compared to the gravity accumulator, because the spring can undergo deformation due to multiple times loading and unloading. Then this is the gas-loaded or charged accumulator. They are also known as hydro-pneumatic accumulator, because in this type the force is applied by the oil using the compressed oil. Here we are using these gases to keep the oil in accumulator pressurized. So the main difference between this gravity spring loaded and gas loaded accumulator is that it is using the gases. This gases loaded accumulator works on the principle of Boyle's law of ideal gas. What is the principle of Boyle's law? It says that pressure is inversely proportional to the area. The storage of potential energy is due to compressibility nature of the gas. Expansion of this gas pushes the oil out of the accumulator. You can see working of this gas loaded accumulator on your screen here. Normally the gas which we are going to use inside this gas fluid accumulator is nitrogen, because nitrogen gas, it is the inert gas which remains chemically inreactive with respect to the various oils.
The gas-loaded type hydraulic accumulator.
As I already told you that this gas charge accumulator works on Boyle's law, which states that pressure is inversely proportional to the volume.
Gases, according to which the pressure of a gas is found to vary inversely with its volume for a constant temperature process. It is popularly known as hydropneumatic accumulator. It applies force to the liquid by action with separator between the accumulator consists of gas-charged accumulator consists of a fluid section and a gas section with separator between the two sections.
This is diaphragm type. This is diaphragm type gas charge accumulator, in which diaphragm is used to separate this gas and the oil here. And on the pressure of this gas, we can keep the oil pressurized here. This is the piston
As the
type.
volume of the compressed gas changes, the pressure volume of the compressed.
This is the piston type gas charge accumulator. In here, piston is used to separate the gas and the oil, like this diaphragm type. And next is below
As the
type
volume of
gas charge accumulator. Here, below is used, in which gas is kept.
the compressed gas changes, the pressure of the gas and pressure of the fluid changes inversely.
Again, this gas charge accumulator having two types: directly contact and indirectly contact. You can see here, this is bladder type accumulator, this is diaphragm type accumulator, this is piston type accumulator, and the spring here is just for supporting purpose, and this is metal bellows type.
A bladder accumulator consists of seamless high-pressure cylinder of the bladder. The flucture prevent. The hydraulic pressure external to the accumulator is higher than the pressure inside the accumulator. Oil from the hydraulic.
Just search on your YouTube if you want to know more about this accumulator. So this is information related to the non-separator or free contact type accumulator. Here, no separation between the oil and gas is made. In separator type, there is a presence of diaphragm below or piston to separate this oil and gas. But here in non-separator type, no such provision is provided. Gas can directly comes in contact with the oil. This oil is kept below in free contact with the gas up above without any separator. It is always in vertical position so that the oil and gas always remain separated. It can handle large volume of oil, which is advantageous. You can see here the diagram for non-separator type. So this is the fluid and this is gas here. This is always kept in the vertical format because density of gas is less, so it floats on the above the oil. So it floats above the fluid. And this, if we plot the fluid pressure against volume of accumulator, then we get its relation like this. You can see on your screen. So these are some laws related to the expansion and compression of these gases. So first type is isothermal expansion or compression, where relation between pressure and volume is PV is equals to constant. And in case if the compression of gases is isentropic, then the relation between pressure and volume is PV raised to the power gamma is equals to C. Then for sometimes it may be a polytropic process. Here PV raised to the power n is equals to C. Then types of separator, we already discussed this. The separator types can be piston type, diaphragm type, and bladder type. This is the piston type accumulator. You can read on your screen. This piston type accumulator is much more effective because there is always a continuous friction between the piston and the cylinder. But in case here in diaphragm type, this disadvantage is removed by the use of this diaphragm. In this type, the hydraulic fluid and nitrogen gas are separated by synthetic rubber diaphragm. At the bottom, I already show you working of this diaphragm type accumulator, and you can read this information on your screen. This is a bladder type accumulator. I already show you it's working in animation format. Here, instead of this piston and diaphragm, here we are using this bladder, and inside this bladder we fill the nitrogen gas. The bladder is filled with the nitrogen gas until the desired pre-charge pressure is achieved. Then this is the significance of nitrogen gas filled accumulator advantages. So student, we are stopping here. I am sharing this PPT on your Google Classroom. You can check there, and also you will get the link of videos on our Google Classroom. We are stopping here now. I am sharing the link for attendance on your WhatsApp group, which will be remain active for next 10 minutes. So we are stopping here, and if anyone having some doubts, then you can directly call me or chat me on my WhatsApp number. Thank you.